All right, 1.4 combinations of functions. So we have two functions right here, f of x and g of x, and we're going to do all four basic operations on them, adding, subtracting, multiplying, dividing. And then afterward, we're going to find a domain. So f plus g of x. So we add those. You can't add what's inside a square root to a non-square root, so we will be just leaving it as this. F minus g of x, x squared plus 6 minus root 1 minus x, f times g of x will be put parentheses around x squared plus 6 times square root of 1 minus x. And finally, f divided by g of x will be x squared plus 6 over square root of 1 minus x. Now for the domain, we see we have a square root, so that square root can't be negative. So what values make these square roots negative? That's everything bigger than 1, right? Because it's 1 minus x. So the domain is going to be 1 and everything less. So we write that as negative infinity to 1, bracket, that needs a bracket because that includes it. Same thing for this one. Same thing for this one. Now what changes is that for this last one, when you divide, when we're dividing, those values can't be 0. We need to keep an eye on that. So the domain for that will be negative infinity to 1, parenthesis. That's be parenthesis because it can't be 1. Now we're going to work with a composition of two functions. So we have here, if you see f of g of x, it's the same thing as writing f of g of x. These both mean the same thing. And what we do is we work right to left when solving these. Okay, so we have g of x. Whatever the g of x function will plug into the f of x function if that's what you have written down. So if I'm trying to find f of g of x of this, everywhere I see an x in the f of x function, I'm going to plug in whatever g of x is. And then I'm going to simplify. So I get 15 minus 3x plus 5, giving us 20 minus 3x. I'm going to do the other way around just so we get it clear. G of f of x. So it's the opposite. So everywhere I see an x in a g of x function, I'm going to plug in 3x plus 5. So it's going to be 5 minus 3x plus 5. A lot of sign errors with these types of problems, folks. It's true that negative sign. Oh, we're going to just get negative 3x because 5 minus 5 is 0. So with these, I'm going to find a domain as well. Okay? So I'm going to find the composition and the domain of f of g of x. So I'm putting in the g of x function in for f of x. So square root of x squared plus 1. That simplifies to x plus 1. Now you might say, hey, this is an all real numbers problem. It's not. Yes, you're right. We have x plus 1 at the end, and that does mean all real numbers. But we started with the square root of x. Okay. Anytime we start with a value where there's a boundary where we cannot include some numbers, we must include it. In this case, we have a square root of x. So these values cannot be negative, right? So it's got to be a domain of zero to infinity. Got to be that. This type of problem here, we can have a little creativity involved. So I have h of x equals 4 over the quantity 5x plus 2 squared. And what they want from you is to write f of x and g of x as a composition of functions. So we want to know what makes this equal to h of x. Okay? So think of f of x and a g of x that would make it this value right here. it might be easier to see what's in parentheses or anything like that, or anything that's combined. And I'm just looking right here and I see a 5x plus 2. So I'm going to put that as my g of x, 5x plus 2. So I'm going to be plugging in 5x plus 2 into something. What is that something? It's going to be something squared, right? So I'm going to put x squared on the bottom here. So it's going to be plugging into this squared right here. Okay, and what's on the numerator? 4. So put 4 up top, and we're good. So that if I were to find f of g of x, what would it equal? It would equal this right here. Okay, so you need to think backwards with these problems, and there's also can be multiple answers, which is nice. Okay, so don't think you have to do it a certain way. Thanks for watching, and we'll see you in class.